Hello students, future doctors and engineers. Welcome to our YouTube channel Medji Exam, the platform where smart work is always preferred over hard work. I am Pansha with cream of the theme series in physics, starting with class 12th. We are doing chapter 1 electric charges and fields, and today we discuss part 3 of that. Topic covered will be superposition principle and the numericals or problems based on part 1, part 2 and also superposition principle. So let us do first superposition principle. See, superposition principle is for system of charges for finding net force or net charge due to system of charges. So let us take here plus Q1 charge. Let us take here plus Q2 charge. Here let us take plus Q3 charge. So this is the system of charges plus Q1 plus Q2 and plus Q3 in the system. These are the multiple charges present, and let us find force, net force on charge this Q3. So net force in charge Q3 due to this Q1 will be in this direction according to Coulomb's law, and that will be that, let us name it as Q31, force on Q3 due to Q1. Similarly, we can write force on Q3 due to Q2, and that will be F3 due to 2. If we take another charge, let here Q4, this is also plus Q4 let. Then this force will also be along this direction, and that will be equals to F3 due to 4. So according to superposition principle, F net will be F31 plus F32 plus F34 and plus so on. That is this. So this is the superposition principle. And when we calculate the force on Q3 due to one of the charge that is Q1, then Q4 and Q2 will not affect that force. Similarly, when we find force on Q3 due to this Q4 charge, then also at that time Q1 and Q2 will not affect that force. Okay. Similarly, this superposition principle can be applied for the finding net electric field for the system of charges also. So let here it is plus Q1 charge, here it is plus Q2 charge, okay, here it is plus Q3 charge, and we have to find let at this point we have to find the electric field intensity. At this point, let this point is P. Here we have to find the electric field intensity. Then here what we can put here, test charge Q0, that will be equals to plus 1 Coulomb we can put here. So at P, electric field intensity, this Q1 will be in this direction, and it is EP due to 1. Similarly, due to this Q2, it will be in this direction, and let it be EP2. Similarly, due to this Q3, electric field will be in this direction, and it will be EP3, like that. So E net will be, in this case, E net will be what? E net will be EP1 plus EP2 plus EP3, so on. So this is the superposition principle. So with the help of superposition principle, we can find force on a particular charge due to multiple charges present in the system, or the electric field intensity at a point due to multiple charges present in the system. So if you see, the statement states that force on any point charge due to number of other point charges is vector sum of all the forces on the point charge due to other point charges taken one at a time. And the important thing is that the individual forces are unaffected due to the presence of other point charges. Okay. So this is superposition principle, and now let us do the questions based on the concept we have discussed in part 1, part 2, including this superposition principle. So question number 1. A charge q is to be divided on two objects. What should be the value of charge on the two objects so that the force between the object can be maximum? Okay, the force is maximum between two charges, these two divided charges. So let the one charge is, let one charge is q, then the other will be q minus q. So according to Coulomb's law, force will be what? If you find the magnitude of force, that will be equals to what? That will equals to k q minus q into q upon, let the distance is r between these two charges, distance is r, then it will be r square. Now it is in the question that the force is maximum. Force is maximum. So if you differentiate the force which is maximum with respect to the charge dq, that is d by dq of f max, this is f max, then that will be equals to 0. This is from the math, that differentiation of maximum quantity or the constant will be 0. So if we write that, it will be d by dq, and f max will be what? K q minus q by r square. Okay, and that should be equals to 0. d by dq of all this, that should be equals to 0. Now here k is constant, r square is also constant, so we can write d by dq, we have taken that outside, constant, d by dq, this will be q, like bracket like that, q minus q square. Okay, this will be equals to 0. So we can write this as, in this case we can write d by dq q minus small q square, that will be equals to 0. That means we have taken this to this side, hence it becomes 0. And now if you differentiate it, as capital Q is constant, so q dq by dq, and this will be minus 2 q dq by dq equals to 0. So from here we can write again q minus 2q will be 0. So 2q will be equals to q minus q, hence q will be equals to minus q by 2. Sorry, this will go to this side, so it will be plus, so it will be plus, so it is q equals to plus q by 2. That means the charge q is divided, we have to divide the charge q into two equal parts so that the force become maximum. Okay, in this case we have used the concept, the concepts are Coulomb's law, we have used the concept of formula of Coulomb's law, and one thing we have used, that differentiation of maximum value will be 0. And we have used one formula, that if we have to differentiate let with respect to time x to the power n, we have to differentiate this, then we can write it as x to the power n minus 1 dx and by dt. We have used this formula to differentiate. Okay, now come to the next question. Two like charges can, like charges repel each other, but if you take a special situation, this is object of big amount of charge, let it is 100 Coulomb plus 100 Coulomb, and there is very small amount of charge compared to this, let it is 2 Coulomb plus 2 Coulomb. So by induction, if these two are conductor, by induction what will happen, this side minus 100 Coulomb charge will be developed. Similarly this side plus 100 Coulomb charge will be developed. But if this distance, see this plus 100 Coulomb is in this region, and this minus 100 Coulomb is in this region, and that way these two will attract and these two will repel, but that repulsion has much more distance. This distance is much, r dash is much more than r. So what happened in NEET, attraction will take place between these two. Attraction will take place, and finally these two will attract also. So the correct option will be C, option C. Next, 2-point charges placed at distance r in air exert a force F on each other. At what distance will these charges experience the same force in a medium having dielectric constant K is given? Means two situations they have given, and they have given that there are same forces, distance may be different. So first let us take air medium. And let the charge is q1, here the charge is q2, let this distance is r. So in this case F air will be, you can write F air, and that will be equals to 1 upon 4 pi epsilon naught q1 q2 by r square. Now if we place the same system in different medium, that medium has charge, that medium had dielectric constant K, and let this distance is now r m, then we can write F medium equals to 1 upon 4 pi epsilon naught K, which is the dielectric constant q1 q2 by r square. Okay, now it is given in the question that F air equals to F medium, it is given in the question. So if we write 1 upon 4 pi epsilon naught q1 q2 by r square, and this side 1 upon 4 pi epsilon naught K q1 q2 by rm square, and in this case if we solve all this will become K rm square equals to r square, because this 1 upon 4 pi epsilon naught and q1 q2 will cancel with this 1 upon 4 pi epsilon naught q1 q2. So this side r square, this side remaining k rm square. So we can write this k rm square equals to r square. From there we can write rm square equals to r square by k, and rm will be equals to r by under root k. So correct answer will be r by under root k, C. In this case the concept involved is of dielectric constant, and that of Coulomb's law. Okay. Next, fourth question is a force F is acting between two charges placed some distance in vacuum. Okay, so let this is charge q1, this is charge q2, and medium is vacuum, distance is r. Okay, a brass rod is placed between these two charges, then okay, in this case F air will be, or F vacuum will be how much? 1 upon 4 pi epsilon naught q1 q2 upon r square. Okay, now in this the medium is changed, all things remain same, q1 q2 distance, all things remain same, but medium changed. So for that F medium or of brass, here brass is the medium, so we can write for F brass equals to 1 upon 4 pi epsilon naught dielectric constant of brass q1 q2 upon r square. Okay, but we know that for any metal the dielectric constant K is 0. For K brass, here also K not 0, infinity. For K brass it will also be infinity, because brass is also a metal. So from that if we see, then F brass will be 1 upon 4 pi epsilon naught 1 by infinity into q1 q2 by r square, that will be equals to 0. So F brass is 0. Okay, now this is option A, but here see F brass infinity, that will not be correct. F brass by vacuum, so F brass by F vacuum, if we calculate, then this is 0 by F air or F vacuum. We have calculated this much, but again this will be 0 because 0 by something will be 0. So answer will be answer D. Both A and B are correct. Okay. In this case again concept involved is of dielectric constant, concept of that, and for metal K is 0, that is infinity, not 0, this, and Coulomb's law. See Coulomb's law. These are the concepts involved. In this question. Next, an infinite number of point charges, each equal to Q, are placed along x-axis. Okay, at x equals to 1, x equals to 2, x equals to 4, x equals to 8, so on. Then electric field at the point x equals to 0 due to this setup of charges. Okay, so let us make the setup. It is like that. I think this is like that. Here is origin. This is 1. This is 2. This is let 4, and this is let 8, so on. And here Q charge is there, here also Q charge is there, here also Q charge is there, here also Q charge is there, so on according to the question. Then electric field we have to find at x equals to 0. In this case, due to all system of charges, we have to find that. So let us apply for NEET, and it is given from the option. We can see that it is in air medium. So if we apply the formula for electric field, then it will be 1 upon 4 pi epsilon naught Q by, this is 1 square, plus for this 1 upon 4 pi epsilon naught Q by 2 square, plus 1 upon 4 pi epsilon naught Q by 4 square, plus 1 upon 4 pi epsilon naught Q by 8 square, plus so on. If we take common Q by 4 pi epsilon naught, we have taken common, then it will be 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus so on. Okay, now we have to solve this. Okay, see, this is a question of sequence and series from math side, and for that I am giving you the formula. The formula for solving this is a by 1 minus r. This a is the first term, this r is the common ratio. Okay, so in this case first term is 1 and common ratio is 1 by 4. See, if you multiply this 1 by 4, it will give the next. If you multiply this by 1 by 4, it will give the next. If you multiply this 1 by 4, this will give the next. So common to ratio is 1 by 4. And if you put it, I am writing here, we can write a first term is 1 by 1 minus 1 by 4. Now if we solve it, 1 by, this will be 4 minus 1 by 4, that is 1 by 3 by 4, and it will finally be 4 by 3. So this, its value will be 4 by 3. Now so we can write here, I am writing here just Q by 4 pi epsilon naught into this whole value is 4 by 3. This 4 will get cancelled, so it will be Q by 3 pi epsilon naught. Q by 3 pi epsilon naught. So right answer is first. Okay, so this is the question in which the concepts applied is, in this question concept applied is superposition principle, electric field, and that is one mathematical formula, a by 1 minus r. That is the mathematical formula, a by 1 minus r. That is also important. And in this question, see, we can make a shortcut also. If you want, you can make a shortcut also. How? See, force due to this first charge, electric field intensity due to this first charge at origin will be how much? 1 upon q upon 4 pi epsilon naught. Okay, but there will be some value of this charge q at position 2 also, due to charge q at position 4 also, due to charge q at position 8 also. So the net force will be more than this q by 4 pi epsilon naught. See, there is only one quantity which is more than q by 4 pi epsilon naught, that is in option A. So without calculating, also by analyzing this question, we can say that yes, the option will be A, because B, C and D, in all that the values are even lesser than the electric field intensity at point O origin due to the first charge, due to the charge q at present at position 1 also. From that we can conclude that without calculation, even we can conclude that yes, by saying the option, that the correct option will be A. Okay. Next question is, when 10 to the minus 19 electrons are removed from a neutral metal plate, the electric charge on it is. This is the neutral metal platelet. Neutral metal plate means this contain positive charge and that same amount of negative charge also. And negative charge is contributed by electrons. So how many electrons are removed? 10 raised to the 19 electrons are removed. Okay. That contain charge how much? Minus 1.6 into 10 raised to the minus 19 Coulomb total charge. This much amount is removed. So how much charge left? Let x charge left. But this x plus this x charge plus this charge will be total 0, because metal is neutral, it is given in the question. So from that, if you find x, solve this will be x plus, and this will be x plus minus 1.6, because this and this will get cancelled, minus 1.6 Coulomb, that will be equals to 0. From that we can find x equals to plus 1.6 Coulomb. So answer will be B, plus 1.6 Coulomb. In this question, the concept involved is of conservation of charges. That concept is involved in this question. Okay. Next is, we have to find ratio of Q, capital Q by small q, when net force on charge capital Q is 0. Okay. Net force on capital Q is 0. Okay. So in this case, let us find net force on this capital Q. So it is a square, so let this side is A, this side is A, this side is A, this side is also A. So net force on capital Q, this is small q, this force will be in this direction, and that force will be K Q by A square, and force due to this small q on this capital Q will be in this direction, because it will repel if we take the same sign. Then it will be K Q by A square. Okay. And this capital Q, if you take the same charges, then this capital Q also repel this in this direction. If you take like that, then, and its force will be, this distance is how much? It will be A, this is A, so this will be root 2A. So this force will be K Q square upon 2A square. This will be K Q square upon 2A square, root 2A whole square. So it will be 2A square. Okay. See, if we resolve, if we find the resultant of these two in this direction, these two forces in this direction, then it will be equals to, how much? Root 2 K Q by A square. Why? It is a vector, resultant of the vector. We know that the formula R equals to, because these two are equal forces, so we can write F square plus F square plus 2 f square cos theta. Here theta is 90 degree, under root of that. So we can write here f square plus f square. If you put cos theta 90, then this will become 0. So it will remain as such. So r will be equals to 2 f square under root, that will give root 2 f. F means physical quantity, a vector. So this vector is this vector is this, both are the same vector. So from this we can write this. Now this and this, if we add these two, that is here 4 is written, it will be force, net force on charge q is 0. So net, if you add these two according to question, net force will be 0. Here the typing mistake, net force will be 0. So just write this as, then it will be, so let us write kq square upon 2a square plus root 2 qq by a square, qq by a square, and then taken together 0. It is given the question that net force is 0. Okay, now we have to solve this. If we take k, q and a square common, then it will be here q by 2 plus here it will be root 2q, root 2q equals to 0. Okay, if you take this to this side, then we can write q by 2 plus root 2q equals to 0, equals to 0. Then from there we can write q by 2 equals to minus root 2q. Okay, then q by q will be minus root 2 into 2. So this is 2 root 2, 2 root 2 minus 2 root 2, it is option B. Okay, in this case the concepts involved in this question, the concepts involved are concept Coulomb's law, and concept of vector also, that is resolution of vector, and finding resultant also, resultant of vector. These three concepts are involved in this question. We can do this question by shortcut also. See, definitely all these forces, if you take the same type of nature of charges, all these forces are in this way. So its resultant can never be 0, but here it is written that force resultant is 0. So for that, either capital Q or small q has to negative, then its ratio will be with negative sign, and here with negative sign there is only one option. So by observing that, we can write directly without calculation that correct option will be B. Okay. Question number 8. A charge q is placed at the center of the line joining the two equal positive charge q. The system of these charges will be in equilibrium. Equilibrium means F net is 0. F net on particular charge is 0. If q is equal to, then we have to find the q. Q we have to find. In this case, let us take this is q, and this is the center point. Let this distance is a from here, so this distance will also be a. This total distance will become 2a, and this is at this point q is there. So let us find in this case the force, net force on this charge. So force on this charge will be net force on this charge. That will be first force on this q due to capital Q. If you find magnitude only, then it will be, and it is not given equal charges. It is which medium? The charge q is placed at the center, line joining to equal positive charges, the system of charges. No medium has mentioned, then we can write it as k also. K, it will be q square upon 2a whole square, that will give q square upon 4a square. Okay, let this is equation 1, and again we find force on Q due to Q magnitude, then it will be K Q by A square. Okay, let this is second. Okay, so net force will be 0. So let us add these two forces. So it is K Q square by 4A square plus K Q by A square, that will be equals to 0, because it is in equilibrium, means net force will be on this capital Q, net force will be 0. If you take here K Q by A square as common, then we can write here Q by 4 plus Q, that will be equals to 0. If we take this side, this to this side, then we can write Q by 4 plus Q equals to 0. This will imply Q equals to minus Q by 4. Minus Q by 4. So option B is correct, minus Q by 4. In this case, yes, Coulomb's law is applied. The concept applied is, Coulomb's law. Coulomb's law, and concept of equilibrium also. Equilibrium. And in that, F net is 0. That is the concept applied in this equilibrium case. F net is 0. Okay. Next question, the x component of force on minus Q1 is proportional to. Okay, we have to find the x component of force on this minus Q1 charge. Okay, so force on minus Q1 charge due to Q2 will be in this direction, because it will attract according to Coulomb's law, and that force we can write as K F, we can write K Q1 Q2 upon B square. This is the force. Now for this Q3 will repel this Q1, so it will be along the line in this direction, and that force will be K Q1 Q3 by A square, as it A square is the distance. Now if extend this y-axis and this negative x-axis, and we see that if this angle is theta, then this angle will be also theta. And now we have to take x component of this force, means we resolve this along the x-axis, that we have to take. Yes, along the y-axis, with the vector knowledge, we can write from the y-axis it will be K Q1 Q3 by A square cos of theta, but along the x-axis it will be how much? K Q1 Q3 by A square sin theta. So the net force along the x-axis on Q1 due to these charges Q2 and plus Q2 and minus Q3, that we have to add, and that will be F net. If you add, F net will be equals to K Q1 Q2 by B square plus K Q1 Q2 by A square sin theta. If you take constants outside, then F net will be K Q1, okay, that is the constant, then it will be Q2 by B square plus, this is Q3 by A square, okay, sin theta. And x component of force is proportional to, they are asking that force is proportional to, so we need to write to constant. If you don't write constant, then F net, we can write this as F net will be proportional to Q2 by B square plus Q3 by A square sin of theta. Okay, so this will be the answer. So the option, this B option is correct. Okay, in this part, in this question, the concept involved is yes, Coulomb's law, Coulomb's law, and the superposition principle also, superposition principle, and resolution of vector, into rectangular component, rectangular component. So 3 concepts are involved in this question. And see, we can do this question by shortcut also. Shortcut we can do by that way also. See, Q2 charge is on the x-axis, so for this no sine or cosine component will be there. Okay, so Q2 by b square, for when b square is there in denominator, in that case no sine or cosine factor will be there. So it is in all that same, there is nothing sine or cosine function. Now see, if we have not calculated, just we have just, if we not calculate, just we take the component of extend this y-axis and extend this x-axis, and if this angle is theta, this angle is theta, so this component will be of this force, the x component will be definitely sine theta, not the cos theta, and these two are in the same direction, so there will be addition sign, plus sign. So in how many options? Only 2 options are there in which plus sign are there, and obviously in which there is in denominator a square, in that case sine component will be along the x, so the sine, so this will be the option. By shortcut we can write this. Okay, next, this the point charge q and minus 2q are placed some distance apart. If the electric field at the location of q is E, then electric field at the location of 2q will be. See, we have studied the concept. If here is a point charge, let q, or any other point charge q, and if you have to find here this, at this point, the electric field intensity, and let if this distance is x, then we can write the electric field intensity E equals to k q by x square. Similarly, based on that concept, if you apply here, one charge is q, another charge is minus 2q, let this charge is here, this charge is here, and the distance is r, then if you find electric field at this q, then that will be definitely due to this minus q charge according to this. So what we have to find, it is given if the electric field at the location of q is E, it is given. So let us write E equals to how much at this location? It will be k minus 2q upon r square. Okay. Now, what will be the electric field? Electric field at this location. At this location, it will be, let E dash, that E dash will be k. Electric field at this location will be due to this charge q by the distance is same, r square. Now we have to find this E dash. Okay, according to the question, we have to find this E dash. So if you compare these two, then what will be the E dash? Let us compare it. E dash by E equals to, E dash is kq by r square, and E is r square by k minus 2q. So kk will get cancelled, r square cancel. So E dash by E will be q by minus 2q. So this q will also get cancelled. So from here we can write E dash will be equals to E by minus 2. So correct answer is first, E by minus 2. Okay students, if you want, for today we can stop here, and if you want to download the PDF, link has been given in the description box. If you like the video, then like, share and subscribe.